Hello everyone. In this video, we're going to focus on proportion from a graphical approach. Our key inquiry questions. How can we identify and use proportional reasoning when relationship do not appear to be 1 to n? The answers for last lesson is on slide 2 and 3 for your reference. Slide 4 contains the 5 for 5 starter question. And the answers are in slide 5. Now let's have a look at how proportionality is connected to the graph. Now let's look at an example question. A theatre group sells tickets to its next performance. Each ticket costs £3. What does the income graph look like? What is the gradient? What is the y-intercept? Now, y equal to kx is part of direct proportionality, where k is the constant of proportionality. Now, in this case, 3 is the gradient and the constant of proportionality. If they charge £4, how does the graph change? Now, have a look at the equation on the graph. That's y equal to 3x because each ticket costs £3. If it was two people, we have to buy two tickets, which would be 3 times 2. We can easily plot them. 1 times 3, which would be 3, 2 times 3, 6, and it moves on. Now, if they charge £4, can you notice it becomes much more steeper? X and y are directly proportional. In this case, x and y are directly proportional because if one increases, the other variable increases. So the relationship between the ticket price and the number of tickets are directly proportional. Let's look at another question. A taxi company charges £2 per mile plus a £3 pickup charge. Now we're going to find out whether the distance traveled and the cost are directly proportional. Now, if we try to convert this into an equation, for 0 miles, it will be £3 because there is a standard pickup charge of £3. And for every mile, it'll be £2. So for 1 mile, it'll be £3 plus £2 per mile, which would get to 5. I'll slightly move this, which would be £5. For if you travel for 2 miles, there's a standard pickup charge of £3 plus 2 times 2, which gives you 4, 3 plus 4, which would be 7. So once we start plotting them, we can join them by a straight line. Now, they are in a linear relationship because it goes on one straight line. However, are they directly proportional? But they're not, because the pickup charge, the variable, do not increase at the same rate. Now, the relationship between two variables that can be graphed, if they have a linear, directly proportional relationship, the line will be straight and it has to pass through the origin. So for direct proportionality, it has to be one straight line. It has to pass through the origin. And we have provided some of the questions, and you can find out whether they're directly proportional or not. Let's look at an example of inverse proportionality. A rectangle has an area of 36 centimeters square. Now, we're trying to find out the relationship between the length and the width. If the width is 1 centimeter, the length has to be 36. So if it's 1, the length has to be 36. If it's 2, the length has to be 18, because 2 times 18 will give you 36. Now, based on different dimensions of x and y, we create a graph, and it looks like this. It's non-linear, and it very much resembles a reciprocal graph. Now, the equation is y equal to 36 over x, because x times y is 36. And you notice that's the constant proportionality, and this denotes the indirect proportion. Similar examples are provided in 15 and 16. Make sure you read it through, have a look, attempt the questions before attempting the proportion graphical activity. Today there will be a live lesson, and more information will be on the stream. Make sure you join them so that you can complete the worksheet and also ask questions.